Welcome to another Fenestration Canada podcast.
And now it's technical time with UL.
Hello and welcome to Technical Time with UL, where we talk about the ongoings of the window and door industry and how UL can help enable safety and sustainability of your products. My name's Ryan Harper and I'm your host for this session today. Joining me is Benjamin Holt, a senior account executive with our UL Environment and Sustainability team. How you doing, Ben?
Good, Ryan. Thanks for having me today.
No problem. So, Ben, you and I have had many conversations, and today more than ever, social and environmental sustainability is really good for business. There's a research report conducted by the Nielsen Company that showed that 2/3 of global consumers are willing to pay more for products and services that come from companies that are committed to a positive social and environmental impact. The problem, though, is that the companies are finding that these environmental processes give them some key challenges in that they can't really effectively communicate that sustainability effort to their stakeholders and the public in general. So I wanted to get your opinion today, Ben, why are companies experiencing challenges in what we call green marketing?
That's a great question. And one of the main challenges we see is green product marketing, is anything but black and white. There are a growing number of eco-labels that has made it difficult to differentiate from a consumer perspective between products that are genuinely environmentally preferable and those that aren't.
So obviously we can support that initiatives. How do we help differentiate the good from the bad?
Great. So yeah, UL offers certifications that ensure that products live up to their environmental claims and are able to differentiate against those that are quote unquote greenwashing, which is a term that refers to products that make environmental claims without proof. So as an example, a greenwashing claim could be something as simply as putting environmentally safe or 100% organic on the product or the website, brochures, whatever. These are blanket statements that don't have any supportive information that can be validated or verified.
So what's an example then of something that UL would validate against for the fenestration industry?
So some of the relevant claims that the fenestration industry focuses on or could focus on recycled content, meaning that the products are manufactured with materials that contain post-consumer recycled content. Mold resistance, which means that products are manufactured with materials that are resistant to developing mold. And probably the most common or popular claim would be zero waste to landfill, which is basically it's a claim that proves that a facility is consistently diverting materials to away from landfill.
Okay. So once a product has been taken their claim and it's been validated by UL, what can that fenestration manufacturer now do with that claim?
Sure. Once the claim has been validated, manufacturers are able to use the UL Green Badge on their product packaging, marketing materials, website, etc. Basically, this badge communicates to customers and prospects that the products have been tested and or verified by a neutral third party and independently validated to have been manufactured and or performed in accordance with its specific environmental claim.
Great. Good information there. Thanks, Ben. Thanks for your time. I really appreciate having you.
Excellent. My pleasure.
And thanks to you for listening. To learn more about how environmental claim validations can help your product, please visit canada.ul.com/fencan, that's FENCAN, or you can email Benjamin directly at benjamin.holt@ul.com. Till next time, thank you very much and enjoy the show.
This is Tech Talks, live conversations about the regulatory environment with Al Yagalis.
Okay, we're now live for Tech Talks, this new episode of Tech Talks. So just want to mention, if you're watching on YouTube, you saw our friends from UL and their small capsule they're gonna do here and there now. So that's a great addition to the show. Just want to let you know, if you're watching on YouTube, you can always ask questions on the YouTube chat. But of course, we're going to prioritize anyone on the Zoom call, our members on the Zoom call. So if you want to attend the Zoom call week after week, you need to be a member, a FenCan member, and you'll get all the instructions week after week by email. If not, you can reach out to us or visit the website. But I just wanted to specify that because we're getting more and more attendance on both sides. So I wanted to clarify that. That being said, good afternoon, good morning for you, Al.
Good morning, good afternoon, everyone.
And a special thank you again to Quanex and UL, our main partners for this show. So what's going to be your topic today, Al?
Today we're going to talk about comparative analysis methods that are recognized in the NAFS standard. These are engineering methods that I haven't heard much talk about at Fenestration Canada over the years. And it adds to the discussions we've had in the last few weeks on AAMA 450, which is engineering methods related to qualifying mullions. The comparative analysis methods are for qualifying products. And I hope that this will be of interest to our members and give them some new options to discuss when they plan their next NAFS testing programs.
Okay, great. So maybe we can start with the presentation, and I'll just remind everyone, if you have questions, please write them in the Q&A section, or you can raise your hand at any time to come and talk with us.
Great. So today we're going to talk about comparative analysis methods recognized in the NAFS standard. And I think there's a lot of value in these for Fenestration Canada members and also all fenestration manufacturers, because these methods apply not only to windows, they also apply to doors. And in the case of one of the methods, applies to unit skylights as well. So it really are useful to know that these methods exist in the the universe of options that we have to qualify the products for structural air-water performance under the code. So why do we need comparative analysis? Well, the first reason actually is to reduce the amount of NAFS testing needed to qualify the various sizes that manufacturers are expected to provide. If we think about the limits of NAFS testing, we are all aware that NAFS tested structural air-water ratings apply only to products up to and including the width and height of the tested size. If you're going 1 inch wider, 1 inch taller, technically your test report no longer covers that specimen. And of course, no matter what sizes you've tested or how many you've tested, you will encounter orders for windows that are going to be a little bit wider, a little bit taller, or both wider and taller than sizes you've tested. And this is a real challenge for manufacturers because you need to balance two things. You would like to choose the optimum test specimen size to get the performance grade that you're aiming for with this product. But you also need to consider that the standard requires you to have testing for all of the sizes that you sell. And so on the one hand, to qualify the largest number of sizes, you would have to test the biggest product, but the biggest size might not give you the performance grade that you need in order to demonstrate that your product line has a performance level the same or better than other people in your industry. So often the test size is a compromise. Ideally, you'd like to qualify everything with that specimen, but you're going to choose a size that may not quite qualify everything. And no matter what decision you make, building designers and window buyers are going to require sizes that are different from what you've tested. And so going back to the lab every time is a very expensive proposition when you encounter this situation. And really, that's why these methods were developed. So if we think about the term comparative analysis, what does it mean? Well, it refers to one of several test-based engineering methodologies that are used to verify the structural wind load resistance of a product based on comparison to a test unit that has been subjected to structural loads. Comparative analysis methods address that practical need to determine structural performance ratings at different sizes than were tested. Now, unfortunately, comparative analysis does not address the air or water resistance properties of the products at other sizes, especially at larger sizes. But there is still a lot of value in these methodologies, as you will see. Now, comparative analysis methods are conservative engineering methods that are based on product performance characteristics that have been determined by testing. So the engineering is done with reference to an existing test report of a product. And having a test report that has tested a product to the highest loads it's going to be subjected to is a very useful kind of a test to have for this comparative analysis methodology. Now, the fact is that fenestration systems are complicated things. You've got the frames, you've got the frame joining methods, you've got glazing beads, gaskets, sealants, and hardware assembled together. And the product's performance depends on all of those elements. And the product will fail when the weakest of those elements fails. And so, and you never know what the failure method is going to be. With experience, you get better at determining those things. But the reality is that a product may fail in various ways. And so the engineering methods used for comparative analysis have as their reference point the test reports. So they ensure that no material or component in the load path of the evaluated product is subject to the loading conditions greater than were tested. So when you have a successful test report, let's say you've tested a product to PG45, well, you know that the hardware has been tested to that level. You know the glazing beads have sustained the pressures at that level. You know that every component in that window system performed up to that level. And so that provides a reference point for the engineering that will follow. Now, NAFS 11 clause 924 tells us two things. And if we look at the last sentence, it says, except as described in AAMA 2502 and or WDMA I.S.11 section 3.4, test results shall be valid only for products up to and including the width and height of the specimen tested. So what NAFS is telling us here is, first of all, these test ratings apply only up to the size tested, unless you're going to use one of these comparative analysis engineering methodologies, which could allow you to extend to determine ratings for products at a larger size. Now, there are two standards referenced in NAFS 11, AAMA 2502-07 and WDMA I.S.11-09. But those are not the most recent versions of those standards. So we have a 2019 version now of AAMA 2502 and a 2018 version of IS-11. Now, generally, engineers, generally for code compliance, we are limited to work with the standards that are presented to us in the code. However, in my experience, engineers generally use the most recent version of a reference standard. And generally, engineers are expected to always be doing their work to the highest professional standard in the industry, to the state of the art at the time that they're doing their work. So they generally prefer to use the most recent versions of a standard for that reason. So AAMA 250219 is likely the standard that an engineer would use, or the AAMA, the WDMA I.S.11 if they were going to use that standard. Now, I need to be clear to say that my knowledge of these standards is based on studying the NAFS standard, studying AAMA 2502 and I.S.11 as documents. I am not an engineer myself. I do not do this kind of analysis. And in my experience in the fenestration industry, I have not actually worked with these standards. So in this presentation, I'm giving you my best understanding of what these standards offer to us and what they can do. I'm hoping in a subsequent show to have a guest with us, an engineer from a test lab who would talk to us about their use of these standards in terms of additional services that test labs can offer to manufacturers. And it's possible that the engineers that do this work, in other words, I may not fully portray the scope of the engineering that is done here. So I'm giving my best effort to make this known to you as a non-expert, as a non-user of the standards, of course, encouraging you folks to look into this to the extent that you feel it would be useful for yourselves, and you'll learn more as you start working with the folks that do the work. So do these two standards, AAMA 2502 and WDMA I.S.11, do they cover the same products? And the answer is not exactly. And you have to look at each standard carefully to determine which product types are covered by the specific methods. AAMA 2502 starts off by telling us that it does apply to both window and door product lines. So it covers both operable and non-operable products, broadly speaking. WDMA I.S.11 says that it applies to both operating and fixed windows, opaque doors, and also to skylight products. So it covers skylights, which AAMA 2502 does not mention. But WDMA I.S.11 excludes combination assembly products to which AAMA 450 applies. And of course, that would be the case for AAMA 2502 as well. Now, WDMA I.S.11 talks about both comparative analysis and extrapolative analysis. And so the comparative analysis may be performed on both individual units and composite units. So a composite unit would have integral mullions, and it can be used as well with opaque side hinge door products. But when it comes to extrapolative analysis, that may be performed on individual units only. So what do we mean by comparative analysis? The definitions within these two standards are slightly different. WDMA I.S.11 provides two different analytical methods. One is called total product comparative analysis, and that applies to window, door, and skylight products, operating and fixed, at sizes smaller than the larger of two test units. So we're going to have a look at that in a few moments. But basically, total product comparative analysis in I.S.11 requires two test reports: a report for a small unit at a high pressure and a report for a large unit tested at a lower pressure. But it also provides a methodology for total product extrapolative analysis. Now that applies, as I mentioned, to individual unit products only, but it allows you to determine structural ratings for products at sizes larger than the size that was tested. In AAMA 2502, the comparative analysis procedure determines design pressure ratings at sizes smaller or larger than the tested size. So, as I say, a little bit of a difference in terminology and a little bit different way that the two standards approach it. And I think it's helpful for us to appreciate both of them. Looking at I.S.11 and looking at the comparative analysis, it applies to the interpolation of intermediate design pressure ratings between two or more sizes of a given product. So the way the comparative analysis works here is that you may have a smaller version of your product tested at a high performance grade and a larger version of that product tested at a lower performance grade. And by interpolation, you can assign intermediate design pressure ratings to intermediate sizes of those products. So that is one useful one useful thing that you can do with this methodology. And this comparative approach applies to a wider range of products than is the case. So yes, so the interpolation means that you are determining ratings between the two extremes of the smallest size and the largest tested. The extrapolation analysis applies to the calculation of lower design pressure ratings for larger versions of the same product. So with extrapolation, you may start out with a smaller product tested to a rather high performance grade, and then using those methods, you can assign design pressure ratings to larger sizes, but the actual design pressures you get will be lower because with either method, the sizes shown in dotted lines, you cannot stress any of the joints, the glazing beads, the hardware components. You can't stress anything in the load path to a greater load than was tested. And so the tested rating constrains the ratings that you're going to get in the future, but it does allow you to determine actual valid ratings for those larger sizes without just based on the tested size itself and the engineer's calculations. So extrapolation goes from a small size to larger sizes for the ratings. In AAMA 2502, the term comparative analysis applies to the calculation of design pressure ratings at sizes smaller or larger than the tested size. So the concept is very much like the extrapolative analysis in IS-11, except that you can do the analysis in both directions. You start out with a tested unit, and you are constrained by the actual forces that were applied to all components in that product when it was tested. But you can obtain ratings for smaller sizes at higher performance grades than you tested, or higher design pressures than you tested, and of course, if you do the analysis for larger products, it will be for lower design pressures, which will be the highest design pressure that is possible with these alternative sizes, given the analysis of the engineer. So let's take a little closer look at some other things we find in the AAMA 2502 document. So it's a test-based procedure to assign design pressure ratings to products at sizes larger or smaller than tested. Products evaluated at larger sizes would have lower than tested ratings. Evaluated at smaller sizes would have higher than tested ratings. I have noted that the AAMA 2502 engineering design rules are more detailed than those in WDMA I.S.11. The WDMA standard gives the engineer, I guess you could say, more leeway in terms of the analysis. AAMA 2502 is more rigorous in terms of just describing what you must consider in the analysis. Not that it's not necessarily more rigorous, it's just has stipulated more clearly the things that must be considered in the engineering design. And AAMA 2502 has a more comprehensive list of reference documents as well. And the analysis, as I mentioned before, excludes evaluation of air leakage or water penetration resistance. At this time, we do not have an ability to assign air leakage or water penetration resistance rates to larger than tested products. Of course, the NAFS test automatically covers the air and water penetration resistance of products that are smaller, at sizes smaller than tested. So it's really only in that extrapolation case where you're applying a rating to a size larger than tested that you have only a structural design pressure rating. When you're using the interpolative method in WDMA I.S.11 or the comparative analysis to a smaller size in AAMA 450, you can rely on the tested air and water ratings for those smaller sizes. And of course, the results of the evaluation are documented in an analysis report submitted under the seal of a registered professional engineer. The application of labeling is interesting because AAMA 2502 was originally developed for use in the state of Florida, where the building code required manufacturers to report performance ratings at the actual sizes that products are going to be supplied in the marketplace. So a manufacturer would have tested a certain set of sizes of their product, but when they're selling smaller sizes or larger sizes of that product, the code required that the actual size ratings would be applied to them. And so the AAMA 2502 method allowed for an engineer to calculate these ratings, and the ratings could be reported on the AAMA 203 Florida label. So this is an example of one of those labels. You can have a manufacturer's logo. This is like a temporary label that we would have in Canada, but it contains your certified performance ratings. In the case of Florida, it actually contains the anchor analysis. So the label has to specify what the anchoring is for various substrates, whether it's wood or other materials that you are anchoring the product to. It includes installation instructions because you can only use the tested anchoring method or the engineered anchoring method when you're installing windows that are rated there. And the actual design pressure ratings at various sizes are reported in the structural analysis portion of the label. Now, we don't have an example of this kind of label in Canada, and we certainly don't have a code that requires it. But it's interesting that there's nothing to prevent a manufacturer from reporting something like the structural analysis ratings that we see here with a product. So if you did have the engineering done for your products with alternative design pressure ratings for other sizes, potentially those could be incorporated into an additional label or a larger label for use in Canada. Alternatively, you could rely on that engineering report for your NAFS labeling as well. And the AAMA 2502, of course, allows reporting of both positive and negative design pressures determined with the engineering analysis. Taking a closer look at WDMA I.S.11, like AAMA 2502, it is a test-based procedure to assign design pressure ratings at sizes larger or smaller than tested. Products evaluated at larger sizes would have lower than tested ratings. Those evaluated at smaller sizes would have higher than tested ratings. The engineering rules are not as specific as those in AAMA 2502, but they do clearly communicate the intent of what the engineer must do. Again, the analysis excludes evaluation of air leakage or water penetration resistance, and the results can be documented in an analysis report submitted under the seal of a registered professional. Additionally, the use of the standard is limited to products with an aspect ratio of less than 10:1. Under the extrapolation analysis option, it allows fixed windows and skylights to be transposed. And that's a very interesting concept because the transposition option extends the range of sizes and frame depths that can be qualified from a single test. So let's consider the case of a tested window with a width of A and a height of B, and it was tested at PG 35. And I'm using hash marks here to indicate a unique head, a unique jam, two unique jam conditions, and a unique sill condition. Because when you transpose a product, it must have the same head condition, it must have the same jam conditions and the same sill condition as the tested product. Provided that those are true, you can then transpose the tested rating of PG35 to the transposed product. And then you can use the extrapolation analysis to actually to increase the tested size of the product with limits of 175% in height or width, or an overall limit of 200% in area. So there are limits to how far you can extrapolate with this methodology. But given that you can also transpose the product, you can actually cover quite a wide range of aspect ratios as well as orientations of the product from a structural point of view. Additional comments here for extrapolation analysis. The glazing edge load on each frame edge must not be greater than the tested specimen. In the language of the standard fastener schedules, I think what they refer to is whatever fasteners you needed to assemble it, whatever construction details of the extrapolated products have to be the same as the what is interesting, though, is that under WDMA I.S.11, the cross-section dimensions of a transposed product are permitted to exceed those of the tested sample. And the standard applies example spreadsheets to show how the calculations could be performed. Again, it's not intended to be used with combination assembly products that are covered under AAMA 450. It does allow comparative analysis, the WDMA version of comparative analysis, which is interpolation between two test sizes, to be used for composite unit products, which have integral mullions. So it allows this because if you've tested it with an integral mullion at the large size and the same integral mullion, or the same, you might say, frame geometry and components at a smaller size, with those two parameters tested, you can then apply that to composite unit products for the in-between ratings. Of course, you need to refer to the standard for a complete description of the parameters to be compared. Here I'm going to express an opinion. I don't know this for a fact, but I do know that the Window and Door Manufacturers Association in the US was formerly known as the National Wood Window and Door Manufacturers Association. And if you looked at the 1997 version of AAMA 101 WDMA IS2, the association at the time was known as the NWWDMA. Most WDMA standards deal with wood frame products, although today many WDMA member companies offer vinyl window and door products as well, some even offering aluminum products. So while the standard does not discuss frame materials, it seems to me that some features of this standard seem particularly relevant to the needs of wood window manufacturers, especially those references to qualifying framing members that vary in face width or frame depth. So just some thoughts to conclude this introduction to comparative analysis. The engineering methods provided in these two standards give window and door manufacturers practical engineering options that can reduce the amount of NAFS testing required to qualify a greater range of window and door product sizes. Canadian manufacturers may not be as aware of these methods, which were developed in the United States and which have been used there for many years. Probably before they predate the NAFS standard as well. So there have been a recognized component of certification programs and window performance ratings in the US for a long time. But I think it's time to the extent that Canadian manufacturers have not yet been aware of these methods, I think it's worth knowing about them and discussing the possibility of how they might be applied in your particular situation with the test labs you work with and with fenestration engineers that you work with who may be willing to undertake this kind of analysis. So that covers this introduction to comparative analysis for Fenestration Canada members. And I wonder if we have any questions or comments, Steph, from folks who are taking part today.
So right now I don't see any questions. Let's stop the screen sharing for a second. If you can turn it off.
Yep.
And go back to... Okay, so for now we don't have questions. Maybe we'll give it a little time. If not, if there anything else you wanted to specify?
So I have asked our guest who was on the show last couple of weeks ago, Tarek Elua of UL, if he would be willing to address this subject. And I believe he indicated he would be interested in doing so. So I'll try and get him back on the line. And I would like to hear, I'd be interested to hear whether any Canadian manufacturers have had experience with this methodology as well, because there are guests on the show who have worked with this methodology and would be willing to share their experiences with it. I think one area that somehow would be really nice if we could find a way to address it is the question of air and water performance ratings at sizes larger than tested. I think some manufacturers who have done extensive testing of their product lines have noticed that the air tightness ratings for their fixed window product lines tend to not vary a great deal. Whether you're testing smaller windows or larger windows, in many products, these are not highly variable properties. When it comes to water penetration resistance as well, a manufacturer may find that they have 15 or 20 NAFS reports for various combinations of their products, and they may find that there's been very little variation, let's say, in the water penetration resistance of their products, so that they've tested some larger ones, they've tested smaller ones, they've tested them as individual units, as part of combination assemblies or composite units. And so they don't see a lot of variation in those properties. So the strict size limitations in the NAFS standard, where the envelope for qualifying a product is limited very precisely to the size tested, that's very relevant for structural performance, because even a very small difference in the height of a mullion, for example, can make a huge difference in the structural capacity of that member. When it comes to the air and water ratings, they're not as sensitive to very small differences in the sizes of a product. So, I think empirically, a lot of manufacturers may feel that they have confidence that their products actually, that the air and water tightness properties of the products may not vary as dramatically as the structural performance varies when it comes to size. And it would be great if there was a way to come up with some kind of, methodology here in Canada to take that into account and to somehow be able to capture that tested performance and somehow integrate it with these engineering methods that allow you to determine product ratings at larger sizes than tested, in order to, define kind of a safe envelope. I know that strictly speaking, by the code and the standards, you can't assign those ratings to sizes larger than tested, but it also seems like a waste to not appreciate the fact that the air and water properties for some products are very sensitive to size, especially sliding sash products, but compression seal products and fixed products, the variations are much smaller. So, so this is an area that I don't know if it's possible to do some work in, but if anyone's interested in pursuing that, I wouldn't mind hearing from you.
Okay, great. So, I mean, we don't have a lot of questions. We don't have questions right now. So, what I'll do you have an idea of what your next week's presentation is going to be already? Like you said, you're trying to.
Yes.
Get,
Next week we're going to have Haya Sagradi, who is the co-chair of the Technical Services Committee and is also responsible for fenestration testing at the UL lab in Toronto. And she's going to be our guest on the show to talk about all things NAFS testing. We talked about the engineering services related to AAMA 450 a couple of weeks ago, but that and other NAFS testing related issues. Next week's show will be kind of an open line show. So I will talk with Haya about issues such as, how can the test labs help manufacturers get the most value out of NAFS testing? What are some missed opportunities that manufacturers sometimes miss out on when they're not really, when they only want to come and do the minimum amount of testing, they don't really want to kind of share everything they want to do with the lab, but sometimes giving the lab more information about your whole product line and is really will help you to get more value out of it. And so we're going to take questions from callers about lab testing questions that they have, and also discuss with her, best practices and basically getting the most value out of NAFS testing when you work with a test lab. So Haya Sagradi will be honored guest on the show next week.
Perfect. Okay, so we'll see you next week, and I just want to thank again Quanex and UL for being a partner for this show. So see you all next week, and for those who are watching us on YouTube, or for those who are on the Zoom call, you can access this show on YouTube anytime now. So see you there, and see you next week.
Okay, thank you very much.
Bye-bye.
You are a member and want to be part of the live recording of Tech Talks? Easy. Visit fenestrationcanada.ca and sign up for the next show.